Hi everyone, let's look at some tricks to factorize natural numbers ourselves. And the trick is actually pretty easy. We're gonna consecutively check the smallest prime numbers out there. So what is the smallest prime number? Remember, 1 is not a prime number. It's also not gonna help us anyway in factorizing a number. So that's 2. And well, it's very easy to see whether a number is divisible by 2 if it is an even number. So what is an even number? That's a number that ends in 0, 2, 4, 6 of 8. And we'll also find out that dividing by 2 is actually rather easy, and we can often do this if the numbers are not too big in our head. And that's also what we're going to do with some examples in this video. The second prime we have to check is 3, and for 3 there is a very nice trick to check quite quickly whether the number is divisible by 3. So what is the trick? You have to sum all digits, and if this sum is divisible by 3, so is the actual number. And again, we're going to use this trick in the example, so it will become clear. This is a very nice trick. And then the next prime number, there's also a very easy trick. So it is just what are the multiples of 5? It's always 5, 10, 15, 20. So all these numbers, they end in 0 or 5. Well, the next number 7, there's not really a trick, or at least not an easy trick that I know of, and we will just have to try and hope whether the number we're at is divisible by 7. So let's make things concrete by doing an example. Let's try to factorize the number 468, and I use this schema which I find very useful. So on the right line we will start writing the prime numbers which are prime factors of 468, which divide 468. And we're going to start by looking at the smallest prime numbers, which is 2, and we see that 468, it ends in 8, so it's an even number, so it is divisible by 2. And well, we can divide 468 by 2. We can do it in our head, or you can do it like somewhere else on your whiteboard, on a piece of paper. So if we have 200, then we're at 400 already, and then we need to divide 68 by 2, which is 34, so we're at 234. This is again an even number because it ends in 4, so it's again divisible by 2. And 234 divided by 2, well, that equals 117. 117 is no longer an even number, so we can skip 2. So we go to the next number, which is 3, for which we have seen a trick. Well, if we sum the digits of 117, this equals 9, which is divisible by 3. So 117 itself is also divisible by 3. And we can divide 117 by 3, maybe in our heads. Well, if we have divided by 3, if we multiply 3 with 30, then we're at 90. So then there's 27 left, which is 9 times 3. So we are at 39. You could then ask yourself, okay, now we have to start again from 2. But we already checked the amount of 2's, the factors of 2's already, so we don't have to consider them again. And this has to do because we know every number can be written as a sum of prime numbers, as a product of prime numbers, and this is unique. So we already seen that there are 2 prime factors too, so we can skip them. So let's stay at the 3. Well, 39. 3 plus 9 is 12, it's divisible by 3, but this is easier just to see. 39 is again divisible by 3, which gives 13, and 13 is a prime number, and we arrive at 1. So we're actually finished, and we can write 468 as 2 times 2 times 3 times 3 times 13. Well, as an exercise, you can try to prime factorize number 12,920. Pause the video, try it yourself. Also gonna do this. So 12,920, it's an even number, so I can divide it by 2. Then we're at 6,460, which is again divisible by 2. So this is 3,230. So you see that dividing by 2 goes rather quickly in your head. Of course, practice more, it's gonna go quicker, as with everything in life. Dividing by 2 again, so we're at 1,615. And so now, well, I can check whether this is divisible by 3, but I can also already immediately see, well, it ends in a 5, so it's definitely divisible by 5. And I can later check 3, just I'm gonna pick like low-hanging fruit here. Well, 300 times 5, that's 1,500. And then I have 100 more to get to 1,600, that's 20. So this is 323, right? So let's revisit the 3. 3 plus 2 plus 3 is 8. It's not divisible by 3, so 323 is also not divisible by 3. So I don't have to bother trying to calculate 323 divided by 3. It's definitely not divisible by 5, so let's check 7. And this is where we have to start calculating stuff to check. We have to divide 323 divided by 7. So we can write this as 280, which is 40 times 7 plus, and then there remains 43. So it's not divisible by 7, because 43 is not divisible by 7. So 7 is a no-go. So we can do 11. So let's check. We can also try doing it, well, we can do it one more time here. 323 in this way, dividing by 11. So what we can do is we can write this as 333, which is 30 times 11 minus 10 divided by 11. So we also see that it's not divisible by 11, because this gives me 30 minus 10 over 11, so it's not a natural number. So what's the next prime number? So 13. So let's try this. Maybe you've seen this schema to make divisions easily, this algorithm. So we're going to check here 32. How many times does 13 fit into 13? Well, that's 2 times. 2 times 13 is 26. Subtract this, then we have 6 here, 63. But 63, how many times does 13 fit into that? Well, that's only 4 times, so that's 40 plus 12, that's 52. If we subtract that, then we are at 11, which is lower than 13. So it's also not divisible by 13. And you see here already that sometimes it requires some work to actually factorize a number, which is the reason why this is actually all being used in cryptography. But anyway, we need to be a bit resilient here. We need to check. Let's check the next prime number, which is 17. 323 divided by 17. 17 only fits 1 time in 32, so we can subtract 17 from 32, which yields 15. Right? Yes. So we drop down 3, 153. And well, 153, let's see. What I can see here is that 170 minus 17 is exactly 153. So 17 fits 9 times into 153. And we subtract this is 0. So I can divide 323 by 17 with as a result, which is 19. And 19 itself is also a prime number. And I arrive at 1. So we just calculated that 12,920 can be factorized as 2 times 2 times 2 times 5 times 17 times 19. Well, in the next video, we're going to see where we can actually use this. Bye.